Welcome to IEC 61850-103 Sampled Values module. In this module, we're going to cover these topics: sampled value concept, UR process bus module, UR sampled value configuration, UR sampled value PRP configuration, digital substation demo, and finally, we're going to recap what we learned in this module. So let's get started. As we have learned in the module of IEC 61850-102, the process bus is intended to replace the hard wires between the ITs and the IEDs. There are three basic types of devices that publish data for process bus: merging units, MU, remote I/O modules, RIO, and process interface units, PIU. RIO publish equipment status in GOOS messages. Merging unit convert AC current and voltage signal to a digital sampled values with a timestamp. Sampled values, SV, also called SAV, sampled analog values, or SMV, sampled measured values. They are used for transmitting digitized instantaneous values of power system quantities, mainly primary current and voltages. Thus, SV can replace the classic secondary quantities. SV are published in the substation network and are able to be subscribed by any devices that make use of them. A PIU publishes both analog and status data in both SV and GOOS messages. Sampled values are especially essential for the proliferation of non-conventional instrument transformers. Other than conventional CTs and PTs, the output quantities of these sensors are not interoperable. The signals are specific to physical principle of the sensor and the vendor's implementation. The output signals are often very small and vulnerable to disturbances, so wiring has to be shielded and kept short. Sensors and devices from different vendors cannot be combined on this level. A standardized protocol like SV removes all these obstacles and enable the application of these new sensors. SV also provide benefits when used with conventional instrument transformers. The AD conversion is done close to the sensors and much of the burden can be removed, thus improving the performance. Finally, the extensive wiring of the instrument transformers, literally involving tons of copper buried in the cable ducts, is replaced by only a few optical fibers, which are immune to electromagnetic interferences. In the module of IEC 61850-102, we learned that IEC 61850-9-1 is about serial unidirectional multi-drop point-to-point link. IEC 61850-9-2 defines the mapping of the abstract sampled values services to Ethernet. It is a generic standard with many options. The sampled rate or the actual contents of the dataset are not defined, so the generic interoperable implementation is almost impossible. To facilitate the implementation and interoperability of devices utilizing SVs, an implementation guideline IG was worked out and later published by the UCA International Users Group. Since the IG defined a subset of IEC 61850-9-2, it became nicknamed the 9-2 Light Edition, or 9-2 LE, but the document IEC 61850-9-2 LE does not exist. Most SV implementation today are based on this IG. It focuses on protection and metering, requiring only a few settable parameters. The dataset contains 4 currents and 4 voltages of the scaling of 1 milliamp per least significant bit for current and 10 milliamp per least significant bit for voltage. The sample rate are either 80 samples per cycle for protection and metering or 256 samples per cycle for power quality applications. The future standard IEC61850-9 for digital interface for instrument transformer will include the implementation guideline as a normative element. Previously, HR has H81 process bus module to work with hard fiber bricks. From version 7.8, it has H85, H86, and H87 process bus module to work with standalone merging unit, like GE Reason MU320. H85 module has two 1 gigabase ports, 1A and 1B. H86 module has 4 1 gigabase ports, 1A, 1B, 3A, 3B, and 4 100 megabyte base ports, 2A, 2B, 4A, 4B. H87 module has 4 100 megabyte base ports, 1A, 1B, 2A, 2B. All the ports use SFP, small form factor pluggable transceiver with SC connector. One clock can be used to synchronize station bus and process bus. This can be IEEE 1588 or IRIG-B. UR behaves as master clock at the process bus level when synchronized from station bus via IRIG-B or IEEE 1588. If time source is lost at station bus, UR continues as master clock at process bus level. UR behaves as a slave clock at the process bus level when synchronized from process bus via IEEE 1588. Station bus support MMS while process bus support IEC 61850-9-2LE and 61869 sampled values. Both topologies support PRP. Process bus support HSR and point-to-point. UR supports goes on both station and process bus. We'll explain more in the following exercise demonstration. The simplest topology is point-to-point. Its pros and cons are pros, direct MU to relay connection. There's no need for another device. And reduced concerns on time synchronization and cybersecurity. It mimics the hard fiber brick architecture, so there's a gentle learning curve. It is ideal for small and remote substations. The cons are sharing data capability limited by number of process bus ports. Most popular topology in the utility is PRP. PRP enables seamless switchover and zero recovery time during a single network failure in substation automation network. It ensures that critical data, such as goods and sample values data, are transmitted without delay in case of local area network defects. The pros of the PRP are increased availability, withstand simultaneous MU disconnect, and more flexible for maintenance. The cons are additional hardware required, like fiber cable and Ethernet switches. Later, we'll do one PRP configuration demo to show how this works with UR relay. High availability seamless redundancy HSR is similar to PRP, which enables seamless switchover and zero recovery time during a single network failure in substation automation network. HSR is used in network topology with rings and rings of rings. All nodes in the ring are doubly attached. The pros and cons of HSR topologies are: pros, reduced hardware requirements, which requires less fiber, cable, and Ethernet switch. The cons are limited availability if simultaneous disconnect, limited flexibility for maintenance. In the UR780 sampled values cross-check setup, the old settings of H81, the security and dependability, are not supported anymore. Instead, depend origin 1 preferred or origin 2 preferred are used here. Now I'm going to demonstrate how to configure process bus in the UR780. So the prerequisite to do this exercise is we need to have a UR with the order code supporting IEEE 1588 with the IEC61850, and also PRP is optional if we want to do the PRP in the future. So for the UR relay I have is a T35 UP3 H86. So the process bus is H86, which has all 8 ports available. And second, we need to have the Ethernet switch, which will support the PTP. So I'm using the reason switch. I'm going to check the IP address for this switch is the 192.168.0.88. So there's 2 settings I want to verify. First is the ports. So from the ports, we can check the how many ports assigned for the 100 megabyte or 1 gigabyte, because depends on which port you are using on the process bus, you need to use the proper port from the switch. So for this demo, I'm going to use a 100 megabyte. Another one is the make sure this switch supporting the PTP, and this switch sets the profile to the power utility 61850-9-3, and also the ports are all checked enabled for the PTP. Another is the equipment we need is the RT430 synchronization, the clock. So for this setup, I got this 199. So I can check the configuration of this clock, RT430 clock. So first we can see the general information. So this one has the Ethernet port PTP enabled. So that's the required the synchronization source coming from this clock. and I cannot use the second port because it's not enabled. Another is the setting. We want to check this under the PTP. And we can see that PTP checkbox is checked, and also the profile set to power utility IEC61850-9-3. So that's the clock and the Ethernet switch, and next one will be the merging unit. So we're going to check the configuration of the MU320. So for the MU320, I already pre-configured the IP address is to 120. Then I can just access into this by login using the password. So under the merging unit, we can check first what is the ID. So this is the ID called the MU320R, which stands for write. I got two merging units, left and right. Then the synchronization. We can see this, we can choose the IRIG-B or PTP synchronization. So for this demo, I'm going to use the PTP. Under the power system, you can choose the CT and the VT, the primary settings. For the goose and the report, we're going to use this goose message in the following demonstration of the digital substation. So I'm going to pass this one, and the most important is the setting under the sampled values. So under the MU01, I set the sample values ID to be MU320R MU0101. So I write this ID on the piece of paper. So later I'm going to type in this into the UR and Vista software. Another information I will need is the MAC address. So MAC address, as we learned before, is that the CD01 is used for the goose and 04 is used for the sampled values. So for here, we just use this default CD04, 00, and 01. So that's all the settings we need to confirm. Make sure that all the equipment has the proper software options before we can start doing the configuration in the UR and Vista software. Now we're going to configure the UR process bus module. Before that, we need first to configure the product setup, the clock. So under the product setup, we can click real-time clock. First, under general, we select this PP/PTP IRIG-B. That means the power profile. PTP and IRIG-B have this different priorities, the sequence. And then under the PTP, precision time protocol, we need to enable the port 2. So this port 2 is enabled. Now we'll go to the setting for the process bus modules. First is general. Under general, we select this independent for this point-to-point connection. And we leave the rest as the default setting. And we have to close this general to open the sample value stream configuration. Okay, so under the sample values, we first select the sample value stream. We're going to choose the 61850 9-2 LE. And for the sample values ID, I just wrote this on the paper, which is the MU320R MU0101. And the MAC address is 04-00 and last digit is 01. And conf ref, the setting is set to 1. Now I'm going to configure the EC bags. So I'm going to choose the B1, bag 1, phase origin as the sample value, CT1, and neutral origin, choose CT1 neutral. And for now I just leave the origin 2 as none. And for the second bag, I'm going to configure this as the voltage. So I'm going to choose this as the sample values VT1, and also the neutral as the VT1 neutral. Okay, at the end, we need to configure the source one. And we're going to apply this B1 to the current and B2 to the voltage. So now I'll save it. So once this source is configured, this source one can be used for the protection element, just like a regular UR relay using the DSP CTVT inputs. Okay, so the setting is saved. Now I just need to reboot the relay just to make this setting be effective. So now I'm waiting for the relay to reboot. Then we're going to check the status and the metered value. Now, after reboot the relay, let's check the status of the clock and also the sample values. So first, we can open the actual values, and under the status, click open the real-time clock. So from here, we can see that the port 2 PTP clock is the source, and also the port 2 state is synchronized. Then under the metering, we can check the source of current, and we can see that current and also the voltage being transferred from the analog into the digital and available under the source. And once this source is configured, then we can just use this source to configure any protection element. For example, in the grouped element, phase IOC. So all these sources are coming from the sample values, and this will be used for the protection operation. Now I'm going to introduce a demo of the PRP configuration. As we learned in the theory portion, for the PRP we need to have two Ethernet switch for the two different network. And for this demo, I chose another UR relay with the order code of L90, and also I switched another merging unit for this demonstration. So first, I'm going to read the order code of this error 90 and check the settings of the process bus. So under the process bus, instead of using direct, this time we're going to use the PRP. So I have to close this one and open the sample value configuration. Okay, for this one we need to use both input for the port 1 and port 2 on the merging unit. And so this is the setting I used under the NVista. And for the sample values ID, we used MU320 underscore MU0102 and also different MAC address. And I'm going to open the MU merging unit software to show where we get this information. Again, we configured the B1, 2, 3, and 4 and assign 1, 2, 3, 4 into two sources. So now let's check the setting in the merging unit. So under the merging unit, this time we're going to add a new device, and this time the IP address is 123. I'm going to add this to a name called PRP. Click OK, then click Retrieve. Enter the password. Okay, from the MU320 configurator, we can check that the setting of this network redundancy. And for this exercise, we're going to set this to the PRP. Now, this is very important for this to work. And again, we check the sampled values using the two merging unit. So for the both of them, MU01 and 02 got a different sample values ID. So that's why I type these two IDs into the NVista and also their relevant MAC address. So the MU01 have the 03 MAC address, and for the MU02 it has the MAC address of the 04. And that's the information I typed into the NVista. And once we type in this configuration, we just need to save and reboot the relay, just like we did the configuration for the direct connection point to point. Other settings, like a clock setup, is the same as a point to point too. I will not repeat that here. Okay, so once we reboot the relay, we can do some test to check this PRP is working or not. Okay, so now let's do a PRP check from the front panel of the relay. So I can see I got 3 ports, port 1 and 2 connected to the Ethernet switch. The status are okay, and the third one shows fail because it's not being used. And also I can check the metered values. I can use the RTT inject a single phase current voltage, and they're displayed here on the front panel. Now I'm going to unplug the fiber cable from the port 1 of the merging unit. Okay, so I can still see that the current and voltage available. So now I'm going to unplug the second one. And now I see the trouble light on the UR front panel and have no current and voltage. If I check my annunciator, which pre-programmed, I can see that sample values are off. Okay, so now I'm going to plug in back the port 2, and I see that sample value off message is gone, and also after a while the relay front panel trouble light is off. So I'm going to plug in back also the second, the first fiber cable to the port. And this test can also be done by unplugging the Ethernet cable from the Ethernet switch. So that means once I plug one of the cable from one of the network, so there's also a backup path for the sample values to supply for the sources of the protection element. So that's how this PRP works for this UR relay. Now we're going to show a mini digital substation example by using the merging unit to simulate the breaker status and also the CTVT input. So both the digital breaker 52A as well as the CTVT will be transferred through this merging unit. So first we need to configure the digital IOs of the merging unit. So now we're going to configure the goose for the message. So we're going to use the digital IO1, and that's the MAC address for this goose, and also the goose ID is MU320IO1. We're going to see this message later once we subscribe in the UR. Okay, so under the dataset, I'm going to choose the digital status. Under the digital status, we're going to choose the GGIO1. That's the binary input 1, and we're going to use this to simulate the breaker status 52A. So once all the settings saved, we can generate a CID file. And I can call this UR digisub CID file. So now from the UR side, I'm going to configure first the status of the breaker, which is under the system. So I'm going to enable the breaker 1 function, and also I need to set this breaker closed condition to be goose. So this will be the Boolean goose message 1, and for the breaker open, I need to program a virtual input to be the opposite of this boolean 1 on. So I can save this one. And next, I'm going to program virtual output. Actually, this should be a virtual output. Save again. So under the flex logic, I'm going to program the virtual output 1. So under this one, I'm going to select the goose boolean, Okay, so this is the goose boolean. The first one is a goose status. So then I choose a NOT gate. And then assign into the virtual output, and by using default virtual output 1. So save this one. So that means that we've got the opposite of this Boolean input 1 as the breaker opens. And last, we're going to import this CID file under the IEC61850. We're going to import this CID file from the merging unit. Okay, so under the goose, Rx goose, Boolean input, I can click AND IED, and I'm going to change to the MU320 CID file and import this URDG sub CID file. Okay, so I need only the input, the 1 for this binary input 1, BIN GGR1. So this will be the only one I need from the merging unit. By the way, this one we can assign into the different to the main CPU goose or the process bus goose. For this test demo, I'm just using the main CPU goose. Okay, so once it's set, just click Save. Okay, the setting is saved to the relay, and also for the merging unit, the setting is also saved. So now I'm going to reboot and now the UR setting is saved to the relay, and the merging unit also the setting is saved. Now I'm going to reboot both UR and merging unit, and I'm going to check this from the front panel of the relay. Okay, so now let's simulate this digital substation. From the front panel, I programmed a single line diagram with a breaker and also the metered values for the IA and the VAB. And I'm going to turn on the breaker simulator by applying a DC to the merging unit contact input, and also apply the current and voltage with RTT. Okay, so I applied the DC to the merging unit IO input and also the current voltage. I can see that both current and voltage metered values and also the status changed into the red color. That's breaker is closed. So all this breaker condition 52A and also the metered values transferred through this merging unit 320, and I'm now going to turn off the breaker and remove the current and voltage. Okay, so I'm simulating the breaker opening by remove the DC to the IO of the merging unit, and which is transferred through a goose message. This is pre-programmed by using the goose message, and also the sample values through the merging unit. So this is a mini version of the digital substation. Both the digital signal transferred through the goose and also the analog are transferred through this sample value with the merging unit 320. So now let's recap what we learned in these modules. In the beginning, we reviewed the process bus from the training CD, and then the concept of the sample values. And after that, we introduced the UR, different types of the process bus modules, and also the topology of the PRP, HSR, point-to-point direct connection, etc. And in the demonstration part, we first demonstrate how to do a direct connection point-to-point, and this will be the same function like the UR-H81 process bus with the hot fiber brick. Then we demonstrate with the PRP by using the two Ethernet switch. And last, we demonstrate a mini digital substation by using the digital I/O modules of the merging unit, so we can simulate the breaker status 52A by using the merging unit. So both the breaker status and the analog CTVT are transferred with this merging unit through the fiber cable to the UR relay. And that concludes this videos of the IEC61850 sample value.